Hello, in this video, we'll be solving these three interesting problems. Question number one, find the sum of the real solution of the equation 4 over x to the power 6 plus 4 over x to the power 3 minus 8 equals to 0. Question number two, find the sum of solution of these absolute value equation. And question number three is a rational inequality. We want to find the solution set. For question number one, we can rewrite this problem as we can write it as 4x to the power minus 6 plus 4x to the power minus 3. And we can see here from here, we know that x cannot be 0. Then minus 8 is equals to 0. Now we have negative powers. And if you look at these negative powers, what can we do? We see if we can transform this to a quadratic by letting u to be x to the power minus 3. Now, when you have negative powers, um, if you have negative powers, then it's better you let your u to be x to the power. You see, what is the biggest? The biggest power here is minus 3. So this is different. When you have positive powers, it's better you let your u to be what? X to the highest power. You take the highest power. So you take the lowest power. For x, for example, if you have, let's say, assuming this is this, right? So in this case, you let u to be what? We'll let u to be the smallest power, which is x to the power 3, right? Yes. But in this case, you see we have negative powers. What are the powers? Minus 6 and minus 3. Which one is the biggest? We lose u to be x to the power minus 3, which is the biggest. So try to understand the difference when you have negative powers and positive powers. Now, what does this mean? This means that u square is going to be what? X to the power minus 6, right? So now this, we can transform this to 4. This will be u square plus 4u minus 8 equals to 0. Now, I've seen a lot of students do this. Here, if you let u to be x to the power minus 6, what will be the problem? If you do u square will be what? X to the power minus 12. Yeah, so this won't work. Now, we can divide both sides by 4 so that you have u square plus 2u minus 4, minus 2, sorry, minus 2 equals to 0. And this we can easily factorize as u plus 2 and u minus 1 equals to 0. So what does that mean? It means that u is equals to minus 2 or u is equals to 1. But what is our u? Let's bring back what is u. U is equals to minus 2. What does that mean? It means that what? X to the power minus 3 is this. Now, how can you write this? If you look at this carefully, you can still write it as this one, right? This is x to the power 3. So if you flip both sides, it means that x cubed is going to be minus what? 1 over 2. You flip the left hand side, you flip the right hand side. So you have this. So remember, this is like 2 over 1. Now, what will be x? X will be like the cube root of minus 1 over 2. So, which you can write as what? We can write this as 1 over what? The cube root of minus 1. No, not 1 over. We can just leave it this way. It's fine. We can leave it this way. We don't have to rationalize. If you want, you can rationalize, but it's not fine. So what is the next one? The next one here, we have u equals to what? 1. So the same approach. So you have this equals to 1. And what does that mean? 1 over x to the power 3 is equals to 1. And this is simply means x cubed is still 1. So x is still going to be 1. So we have these two values as the values of x. As the values of x. So, but what does the question ask us to do? It asks us to find the real sum, the what do you call it, the sum of the real solution. Look at this. This is a real number, right? It's a real number because you have cube roots. So and you have a negative number. So we don't have to worry. Our solution set is going to contain this cube roots of minus half as well as 1. And now the sum, we can just write this and that's it. That is the sum. Okay, so you don't have to try to, uh, you can simplify this further if you want, but we can leave it this. So let's move to next question. The next question is this. We can rewrite this as what? We want to find the sum of the solution of this equation. Now this, if we look, we can write it as root 3x minus, this is for t 12. 12 is what? The same thing as 4 times 3 squared. So this we can keep, minus 6 equals to 0. Now this is the same thing as root 3x minus, this is 12. 2 can come outside. So no, so you have, you can take root 3 outside. We can have root 3. So you will just have 2 root 3 whole square because 2 can go outside from 4. Then this is minus 7, x minus 2 minus 6 equals to 0. Now here we can factor root 3 so that you have x minus 2 whole square, and this is still same. Now this is the absolute value. There is a square root here. We can split this actually using some of the properties. We can put the square here and put the square here as well. So don't forget that if you have absolute value of AB is the same thing as absolute value of A times absolute value of B. So if you have a square here, you can distribute the squares, not a problem. So that is what will happen here. And here, simply this will just become 3. And you have this one. So here, this point, we can make a substitution of u to be absolute value of x minus 2. And this will become then a quadratic equation, 3u squared minus 7u minus 6 equals to 0. Then we try to factorize. To factorize, it means 3 times minus 6. So we have minus 18 and we have minus 7. So we look for two numbers that we multiply to give us minus 18 and we add to give us minus 7. And you can think carefully. We see minus 9 and 2 will do the job, because minus 9 times 2 will give us minus 18. Minus 9 plus 2 will give us minus 7. Now we can divide this by what? Both sides by 3, and this will simplify to minus 3 over 1. So this means this, factorize this, is just take this one as the coefficient of x, so which is x. Then the numerator is minus 3, so minus 3. Then here, the denominator here, the coefficient is 3, so take that 3 as the coefficient of x. Then the numerator here is 2, so this will be plus 2. And this is equals to what? 0. Okay, now this means that what? X equals to 3, or from here, we can get that x is what? Is minus 2 over 3. Simply, what did you do? The 3x plus 2 equals to 0. You'll get x is minus 2 over 3. Okay. Now, we bring back u. What is u? So, um, so oh, this is not true here. We should have u here. Not so, because the quadratic is in u. So everything here should be about u. And here also should be 3u plus the 2. Okay. Now, the solutions we have are not the solution for x yet, but the solution for u. So u is equals to 3, or u equals to minus 3 over 2, 2 over 3. Now, let's bring back what? We need to bring back what is u, right? Now, what is u from the beginning? U is what? Absolute value of what? X minus what? 2. It's equals to 3. That's what it means. Or absolute value of x minus 2 equals to minus 2 over 3. Now, clearly, we can what? We can reject this one, because an absolute value cannot be negative. So we have this to deal with. And what is this? Remember, when we have absolute value of a equals to b, where we have b to be positive, we say a is equals to b, or what? A is equals to minus b. Now we can use this to finish this up. This means that x minus 2 equals to 3, or x minus 2 equals to what? Minus 3. So this gives us x is equals to 5, or x here will be minus 3 plus 2, right? Which will be minus 1. Okay. So what's the solution set? It means our solution set is just minus 1 and 5. So here we are not getting anything from here, so we reject it totally, because absolute value of x, the smallest absolute value can be 0. So either positive or 0, so it cannot be negative. So now the sum of solution, it's simply what? Minus 1 plus 5, which is 4. So this is the sum of the real solution of these absolute value equation. All right, so let's move to the next question. So this is question number 3, is to find the solution set of these rational inequality. So what we can do here it's we can try to simplify. Now, if you look at this, we can factorize this as what? X plus 5 squared. Then all to power what? 6. X plus 5 squared is the same thing as x squared plus 10x plus 25. Divide by x plus 2, 17. X minus 2, 18. So this becomes x minus 1 to power 3, x plus 5. So here will be 2 times 6, which is 12. Then this is x plus 2 power 17. Then x minus 2 to power 18. Now what is left is for us to use the critical value method. And now what is the critical value method? The critical value method, what we need to do is to what? Is to get the critical values, which are the zeros of the numerator and the denominator. So from the numerator, we'll get 1. And also, we'll get what? Minus 5. From the denominator, we'll get minus 2 and 2. So these are all the critical values. Now, we go to the table. So the table here, we arrange the critical values beginning with the smallest, which is minus 5. Then we have minus 2. Then we have 1. Then 2. So these are the factors: x minus 1 to power 3, x plus 5 down to power 12. Then we have x plus, from the denominator, we have x plus 2 to power 17. Then we have x minus 2 to power 18. Okay. Now, using this critical value method, the zeros of the denominator, remember here we have greater equals to 0, we have greater equals to 0. Now, the zeros coming from the denominator, we usually leave them open. So it means you will open at 2 and open at where? Minus 2, because they are coming from the denominator here. So if you have 0 here, it will be, you can divide by 0 to be undefined. But now the zeros coming from the numerator, which are x equals to minus 5, we close it, and 1, we close it also, because we have equals to 0, because at x equals to minus 5, we will have 0. At x equals to 1, we'll also have 0. Okay, now let's go for the sign test. Now, if you look at this one, the some of the powers are even, like this one, x plus 5 to power 12, even, so it means it's going to be positive everywhere. Now, the last one also, x minus 2 to power 18, is also positive everywhere because it's even power. So now let's test some values. Between minus infinity and minus 5, we can take minus 6. If you take minus 6 and put it here, you have minus 6 minus 1, which is negative number, minus 7 to power 3 will be negative. Take a number between minus 5 and minus 2, we can take minus 3. Minus 3 minus 1 is minus 4 to power 3 is also negative. So here is also negative. Between minus 2 and minus 1, we can take 0 is there. So put 0 here. 0 minus 1 is minus 1. So here is still negative. Between 1 and 2, we can take 1.5. If you put 1.5, 1.5 minus 1 is 0.5, which is positive. Then to power 3 is still be positive. Now, then take 2 here, take a number bigger than 2, for example 3. 3 minus 1 is 2, so power 3, you will still have positive. Now we're still coming back here, so we have the third term now. Let's deal with this term now. That's x plus 2 to power 17. We're using minus 6 here in this interval. We're using minus 6. Now, minus 6 plus 2 is minus 4 to power 17. Definitely remains negative number. Now, between minus 5 and minus 2, we're using minus 3, right? Yeah. So minus 3 plus 2 is minus 1 to power 17. This is still minus. Between minus 2 and 1, we're using 0 here. So with this 0, we put 0 here. 0 plus 2 is positive to power 17. So this is positive. And between 1 and 2, we're using 1.5. 1.5 plus 2 is 3.5 to power 17. Then we still have plus. And take a number bigger than 2, say 3. 3 plus 2 is 5. This is all positive. Now, let's get the final sign, whether positive or negative, in which interval. So here you have negative, negative, positive. So this is positive. You have negative, negative. So you still have what? Positive. Then here you have negative, positive. So you have negative. And here you have positive, positive. So this is positive. And also here positive, positive. So we have positive. Okay. Now, since the question is asking for greater equals to 0, what can we do? For greater equals to 0, we need all the interval where it is positive. So let's look at this carefully. You see that between minus infinity, so this will be our solution set. Between minus infinity up to where? Minus 2. Minus 2 open. Yes. It is what? It is all positive, right? Now, if you look between minus 2 open and minus 1 is negative, so we cannot take it. Then we need to take this again. This is positive. Now, remember, why are we taking positive? Because here we need where it is positive, right? Then here we have another positive here, so we have to union. Then here we have to take close because it is close at 1. Then we have to go to 2, which is still open. Then we have to take from 2 to where? To infinity. Now, we cannot take from 1 to infinity because it is open at 2. If you take from 1 to infinity here, it means you are taking also 2, but we know it cannot be 2 because 2 is open. Is that okay? So this is the solution set for this particular problem. Now, let me just do like let me just answer one more question here. Now, let's assume this is now changed to less than equals to 0 instead of the positive. So it means, let's have another solution set here. Now, please take note, this solution set now is for, not for this one, but for this one. Let's assume we have less than equals to 0. For less than equals to 0, it means we are going for where? We're going for the negative interval. So as you can see, the negative interval we have where? We have just here, right? So this will be minus 2 open to 1 close. This will give us negative. But there is something. Because we have equals to what? Equals to 0, it means we have to take all the values of x where the rational inequality is 0. And if we look carefully here, how many places do we have 0? We have at 1, because this one is closed. At 1, Remember, at 1, you will have 0 because it's in the numerator. But it's fine since 1 is already closed, is enclosed in this interval. But if we look at minus 5, you see at minus 5, what do we have? We have 0. So this is closed. So it means we have to include where? Minus 5. So this is the solution set when you have less than equals to 0. And this one is, the first one is when we have greater than equals to 0. Okay, I hope these questions are clear now. Thank you for watching. So the right hand side, what do we have? We have the square root of 3